In the last video, we talked about the estimating the slope at a particular point by picking a point on either side. And we talked about the fact that as we pick points closer and closer to the point we're interested in, we get closer and closer to the real slope. And we kind of started talking about limits. I want to change gears here, but maybe end up at the same spot thinking about this necessity of a limit. So, a race car moves with velocity given by the graph to the right. How far has the car moved in 5 seconds? So, you've got something that's moving at a constant of 10 meters per second for 5 seconds. So, 10 meters per second multiplied by 5 seconds tells us we went 50 meters. Now, I've written it this way so you can maybe recall from doing some conversions with units in science class that, meters per second multiplied by seconds, those cancel, and that's how we justify that it's just 50 meters. And of course, this is a pretty easy calculation. If I tell you something's going 10 miles an hour for 15 hours, you can figure out how far it went. But this is a nice way of looking at it. Now, from a geometric standpoint, we took this meters per second, we multiplied it by seconds. Meters per second multiplied by seconds equals meters. So we found the area. Okay? We found the area. Easy enough. Well, what if it were a little bit harder shape? A race car moves with velocity given by the graph to the right. How far has the car moved in 16 seconds? Well, I showed you the easy one to show you that geometrically we're really just finding the area. So now, why not do that again? Okay, so we can find this. Just pay attention to the fact that we're going by twos. So, we count up, we say, well, there's 1, 2, 3, 4 boxes, but each box is 2 by 2, so it's actually 4 by 4, it's a square. This is actually 16 in here. Okay, let's do this box second because I think that'll be easy. We got 1, 2, 3, 4. 2, 3, 4. So we got a 4 by 4 square here, but it's actually 2 units. So it's 8 by 8. This is 64 units right here. So each box, remember, is 2 by 2. So here's 4 and 8. And then this one makes a box, so that part is 12. And this is a triangle. If you want to think about, you got 2 units here. You've got 8 units here. So 2 times 8 divided by 2. This is 8 units. So we add them up. 8 plus 64 plus 12 plus 16. So it is 100 meters. Okay, so it's just area. Easy enough, as long as it's all nice and geometric. So what happens when we get something like this? Okay, this situation is after passing a truck, car's velocity decreases. So maybe you speed up to pass, but then you slow back down to the speed limit. Well, how far has this car traveled? Again, we're thinking area, and really you look at this and you say, well, this is, from here on, it's not hard, right? It's each square looks like it's 10, so we've got from 30 to 50, from 25. So this is 25 down here. This side goes by 10, so this is 60. 60 is over here. So we could easily figure out the area of that. And then we could go further and say, well, you know what, this is also 25 by 60. But the trouble becomes this shape. We could estimate. We sure could estimate. We could go back and say, well, you know what, we got a whole box here. We got almost a whole box here and almost a whole box here. And maybe I could use this box to kind of fill in those 2 boxes, and I could kind of estimate. Okay? But what would make the estimate better? Well, probably smaller boxes or smaller intervals, similar to what we said before, where if we had smaller boxes, if we divided these up even more, something like this, we probably could have an even better idea counting up whole boxes and partial boxes and filling things in. The idea here is that as we add more and more and more boxes, we'd get closer and closer to the real area. Okay, so more boxes yields closer to the actual area. And again, we're talking about limits. Now, in the previous example, when we talked about limits and we said, well, geez, if we could just make that interval smaller and smaller and smaller. Well, that was really a limit saying that we want the intervals to get closer and closer to 0. This is a little bit different. What we're saying here is we want the number of boxes to grow infinitely. But we could liken it to the previous example by saying, well, we want each box's side to get closer and closer to 0, which would yield an infinite number of boxes. So again, this all comes down to this idea of a limit, which we're going to start talking about now.